So let's go with colligative properties. Basically, the colligative property are those property now which depends on the number of solute particle. Okay, it does not take care with the solvent. Only it depends on solute particle. So the property depends on the number of solute particle, not the nature as well. Okay, it does not depend like whether the solute is polar, non-polar, doesn't mean that. Okay, only how many number of solute particle present in that solution, it will depend only on these property. So basically we have 4 types of colligative properties, right? What are the 4 types of colligative properties? Relative lowering of vapor pressure, elevation of boiling point of the solvent, depression of freezing point of the solvent, osmotic pressure of the solution. All right, so these are what? These are the 4 types of colligative properties. All right, these are the 4 types of colligative properties. Let us see number 1. Now everything is same, right? सभी वही same concept है, बस colligative properties, they are a kind of property which will fluctuate based on the number of solute particle. Here you have 4 types of colligative property. You have to understand, you have to remember their formula and you have to practice numerical, because यहाँ से आपको सिर्फ numerical पूछे जाएंगे. Okay, only you will get the numerical. So when a non-volatile solute is added to a solvent, okay, when a non-volatile solute is added to a solvent, its vapor pressure is decreased. This is called lowering of vapor pressure. Okay, so what do you mean by that? Now suppose when a non-volatile, right? Now we are talking about non-volatile, not a volatile. Okay, so when a non-volatile solute is added, which is not non-volatile, which is not contributing in the vapor pressure, added to solvent, its vapor pressure obviously decreases, na? Because in that case only you have a vapor pressure due to solvent, not due to solute. So obviously it will decreases only. Okay, so the relative lowering of vapor pressure, delta P, what will be the relative lowering of vapor pressure? Delta P by P naught A equals to XB. Delta P by P naught A equals to XB, right? And what is delta P? Delta P, we know that P naught minus P. Okay, so you just write down in case of this P naught A, and delta P is P naught XB. From here you can calculate P naught XB. So from here you can say that delta P is directly proportional to the mole fraction of only component B. Okay, it will directly proportional to the mole fraction of component B, because component A is what? Component A is non-volatile. So only you will get a vapor pressure due to component B. Okay, so the vapor pressure of the solution is directly proportional to the mole fraction of component B. आई बात समझ में? So ये है relative lowering in vapor pressure. क्यों relative lowering in vapor pressure का मतलब क्या हुआ कि अगर non volatile आपने solution में mix कर दिया, ठीक है, solute, तो उसका जो vapor pressure था वो कम हो जाएगा. Then relation between lowering of vapor pressure and molar mass, right? The relation between lowering of vapor pressure and molar mass. So according to Raoult's law, relation, now see how you are going to relate the relation lowering in vapor pressure with molar mass. So basically according to Raoult's law, lowering in vapor pressure equals to mole fraction of the solute. This is lowering in vapor pressure. Delta P by P naught A is what? lowering in vapor pressure. So lowering in vapor pressure equals to mole fraction of the solute. XB is the mole fraction of the solute. Substituting molality in the above equation. Now what you have to do? You have to just add the molality formula. So delta P by P naught. In case of mole fraction, WB by MB, MA by WA, where weight of this WB is weight of solute, MA is the mass of, molar mass of what? Molar mass of component A. Similarly, mass of component B and the weight of component A. Alright. So this is your one of the problem. Just try to solve. What you have to calculate? The vapor pressure of a solution containing 5 gram of urea dissolve in 100 gram of water. 5 ग्राम यूरिया को 100 ग्राम वाटर में डिसॉल्व किया गया. द वेपर प्रेशर ऑफ प्योर वाटर एट दिस टेम्परेचर इज 23.8 mmHg. ओके, वेपर प्रेशर जो है प्योर वाटर का इस टेम्परेचर पे इतना है. सो नाउ व्हाट यू हैव टू कैलकुलेट? द वेपर प्रेशर ऑफ सॉल्यूशन. ट्राई टू सॉल्व बाय योरसेल्फ. Put it into the formula. First of all, write down what is given. Okay, so the given data is mass of solute 5 gram, molar mass of urea 60 gram, mass of solvent 100 gram, molar mass of water 18 gram. So now vapor pressure is 23.8 mmHg. Calculate the mole of solute. So moles of urea is equal to mass of urea divided by molar mass of urea. Simply you have to calculate first of all the mole of urea and water. Now the mole fraction, solvent, mole solvent upon solute, you will calculate the mole fraction. Then write down the Raoult's formula. Okay, note कर लीजिए इसको and see how it is written, right? Like this only you have to solve for your exam as well. ऐसे ही आपको एग्जाम में भी सॉल्व करना है. ओके, ये वाला भी थोड़ा सा सॉल्व कर लो. Right now the number second is the elevation of boiling point, right? Elevation of boiling point is what? Delta TB. Okay, so now the difference between the boiling point of the pure solvent and that of solution is called elevation of boiling point. Elevation का मतलब क्या होता है? बढ़ना. ठीक है, तो elevation, see vapor pressure is decreasing when the number of solute increases. Here the temperature, the elevation in the boiling point elevated. The difference between the boiling point of the pure solvent and the solution is called elevation in boiling point, which is represented by delta TB. So delta TB is what? Delta TB is basically the change in the boiling point, the difference in the boiling point of the solvent and the solution. Okay, so delta TB is TB minus TB naught. So where you can say that it is directly proportional to molality, not molarity. Relative lowering in vapor pressure, molarity. Here it is molality because it is temperature dependence. That is temperature independent. So delta TB is equal to KB into molality, where KB is molar elevation or allotropic constant. Alright, so इस ग्राफ में क्या दिख रहा है? See, the vapor temperature and the vapor pressure. This is the temperature of pure solvent. This is the temperature of solution, right? Now at 1 atmospheric pressure, right, here what you have seen, the solvent, the vapor pressure, the temperature, see here the solvent temperature is increasing and this is the solution temperature. All right, so what you will see, there is a change in the temperature. How you will relate with mass of solute, since delta Kb is directly proportional to molality. So Kb is the constant one. So just write down Kb and the molality formula, Wb by Mb 1000 by Wa, right? Put from here you can calculate the mass of solvent. तो वही है, same formula, molarity अगर आपको याद है तो you can calculate the TB, delta TB and the relative lowering in the vapor pressure as well. Okay, am I clear? Right. So let us solve one question. What is the boiling point of a solution prepared by dissolving 2 gram of NaCl in 100 gram of water? Right? Question is there. Just try to put it into the formula and try to solve. Yeah, any doubt guys, anyone? समझ में आ रहा है कैसे करना है? Formula is given, right? See here, what is given? Mass of solute is given. Mass of solute NaCl 2 gram is given. Molar mass of NaCl you are able to calculate, which is 58.5 also given. Mass of solvent is 100 gram and Kb value is also given. Okay, so from here, first of all, what you have to do? You have to calculate the mole of NaCl. Moles you can calculate mass upon molar mass. So mass of NaCl 2 gram, molar mass given. So this is the mole of NaCl. Similarly, molality is calculated by moles of solute divided by moles of solvent in 1000 in 1 kg. Okay, so moles of solute you have calculated, mass of solvent in kg is given 0.1. So you can calculate the molality as well. So now consider the want of factor from here. Since NaCl has 2 ions, so value of I is 2. Now applying the formula, delta Tb is equal to I Kb into molality. So this is the formula of boiling point elevation, where small I is what? Want half factor. We will discuss later, but this is the want half factor. So delta Tb is equal to 2 into this, you will get the value 0.355 Kelvin. So calculate the new boiling point. The boiling point of pure water is 373 K 100 degree Celsius. So from here, like directly you can calculate the value. Clear? Now the depression in freezing point, right? Depression in freezing point. Depression का मतलब क्या हुआ? घटना. Elevation increasing. Okay, so freezing point is the temperature at which the solvent or the solute, like the solution, freezes. Adding a solute lower the freezing point of the solution as compared to pure solvent. So you have heard na, like if you have to basically freeze the solvent, right? Pure solvent, like agar koi water hai, so that water will freeze early as compared to ice cream which has a solute within them, right? So you can say, just take an example, milk and water. So milk will take time to freeze, but yes, water will freeze early. Why? Because Water is only pure solvent, only H2O molecule, but milk is having so many number of solute molecule within them. So as the number of solute molecule increases, there is a decrease in freezing point. So that is what we can say, depression in freezing point. So adding a solute lowers the freezing point of the solution compared to pure solvent. Alright, so delta TF directly proportional to molality. Okay. It is also directly proportional to molality. See, it is TF, that is TB. Don't get confused. TF into delta TF is equal to KF into molality. KF is what? Cryoscopic constant. KB is what? Eleuthoscopic constant. So molar depression constant is the depression in freezing point. How you can calculate with molar mass? So TF is equal to Km into M. Small m is the molality. So molality formula is this. So ultimately you will get these formula. So now just try to practice numerical based on these formulas. Another question. Now here you have to determine the freezing point of a solution containing 1.5 gram of ethylene glycol in 200 gram, right, of water. Just try to solve by yourself with the formula. Everyone. Okay. So determine the freezing point of a solution containing, so mass of solute given 1.5 gram, molar mass is given 62, mass of solvent is 200 gram, right, which is 2.2 kg, and KF is given. Simple wahi formula lagega, right? First of all, you have to calculate the moles of ethylene glycol, mass upon molar mass, and the molality, mass of solute upon solvent. So this is by this. Now applying the formula KF into molality. So now KF is given, molality you have calculated, multiply, you will get the answer. Now the new freezing point of pure water is 2 minus 273. You will get the new freezing point of the pure water. Okay, so note it down. It is also based on the same formula. Right? Now next we have osmotic pressure. Osmotic pressure, first of all, it is related to osmosis. You know, you have heard about osmosis and the diffusion, right? What is osmosis and what is diffusion? In case of diffusion, there is a movement of molecule from higher concentration to lower concentration. In case of in case of osmosis, the movement of solute particle is from lower to higher, and the movement of, you can say, the movement of solvent is from higher to lower. तो बस solute में उल्टा होता है, otherwise same with diffusion like osmosis. Another difference is in osmosis, you have a semi-permeable membrane. You require a semi-permeable membrane. Okay, there is a passing of solute and solvent through a permeable membrane. In diffusion, you are not required with that membrane. ओके तो ये तो ऑस्मोसिस एंड डिफ्यूजन है. What is osmosis? If a solvent and solution are separated by a semi-permeable membrane, the solvent molecule flow through the membrane from pure solvent to solution. So here what happened? The solvent molecule, suppose you have a solvent and you have a solution, right? So what happened? They are separated with a membrane. So now the solvent molecule is moving from solvent to the solution. This process of flow of solvent is called osmosis. तो जब solvent solution की तरफ move करता है this through semi-permeable membrane, this is what we call osmosis, right? The excess pressure required to prevent the osmosis is called osmotic pressure. So if now you are applying some outside, you are applying some external pressure to prevent this flow, then that pressure is called osmotic pressure. Okay, that is what we called osmotic pressure. So here osmotic pressure represented by pi. Okay, so it is directly proportional to concentration, directly proportional to T, temperature. Okay, so basically pi is Nb by V into RT. Nb is what? Wb by Mb. It is a number of moles only. Okay, so you just put it into the formula and you will get the value. So this is what? This sign is what? Osmotic pressure sign.
अब एग्जाम की तैयारी को और बेहतर करने के लिए हमारे चैनल को लाइक, शेयर और सब्सक्राइब करना ना भूलें।